This is example 6.8 on page 228 of our text, and this is another variation of the ideal gas law equation that allows us to use mass, ideal gas constant, temperature, pressure, and volume to solve for the molar mass of a gas. So we can do a rearrangement of the terms in the ideal gas law, split some things up, and come up with the equation shown on the screen, where big M means molar mass, that's in units of grams per mole, is equal to little m, which is mass, times R, the ideal gas constant, 0.08206 liters times atmospheres over moles times Kelvin, times T, still in Kelvin, over P, pressure in atmospheres, and V, volume in liters. So this rearrangement allows us, if we're given mass amounts, to solve for molar mass, or if we're given molar mass, to solve for mass amounts. So the problem here states that a sample of gas has a mass of 0.311 grams. Its volume is 0.225 liters at a temperature of 55 degrees Celsius and a pressure of 886 millimeters of mercury. So they want us to find the molar mass, our big M. So we're given mass, which is little m, and that is 0.311 grams. Our ideal gas constant is always the same, 0.0206 liters times atmospheres over moles times Kelvin. Our temperature is given in Celsius, 55 degrees. I'm going to add 273.15 to it to get it in Kelvin for our formula purposes. And that's going to give us a temperature of 328.15 K. Our pressure is 886 millimeters of mercury. I'm going to go ahead and solve for that in atmospheres. So divide that by 760 millimeters of mercury, 1 atm on the top, and we get a pressure of 1.1658 atmospheres. And then our volume, we don't have to do anything to, is equal to 0.225 liters. So now we can plug into our equation and solve for molar mass. So big M is equal to the mass, 0.311 grams, times the gas constant, 0.08206 liters times atmospheres over mole times Kelvin, times temperature, which is 328.15 K. All that divided by pressure, 1.1658 atmospheres, and then divided by volume, 0.225 liters. So in this problem, atmospheres cancels, liters cancel, kelvins cancel. Only units I'm left with are grams per mole, which is equivalent to the unit for molar mass. So in this problem, big M, after we solve everything else in the problem, is equal to 31.9 units of grams per mole. So that's how to solve for molar mass using a rearranged ideal gas law equation.